6.9. The figure shows the probability distribution of a discrete random variable x. Which of the following best describes this random variable? All right. So if we were just looking at this histogram and we were trying to describe it using SOC-V, right, we might say that the shape is kind of symmetrical, maybe slightly skewed to the right, but it's mostly, symmetric. No outliers. Center probably around 2 or 3. Variability, it looks like the range is 6, right? It goes from 0 to 6. Okay. But here, let's focus on the center, right? So I'm just making a note that from my observation, the center is approximately, let's just say 2.5. Right? It's somewhere right here. Okay. Now, the answer choices here, there's only 2 types of random variables, binomial or geometric, with different values, different parameters. But because we know how to calculate the mean of a binomial and geometric random variable, we can just calculate the mean for all 5 of these choices and see which one produces a value close to 2.5. Because anybody can visually see that the center is going to be, probably around 2 or 3. Okay, if you need to see the formulas, let me pull it up real quick. It's right here. Okay, so for a binomial distribution, the mean is just n times p, number of trials times the probability of success. For a geometric distribution, the mean is 1 over p, so it's the reciprocal of the probability of success. Okay, so if we look at choice A, n times p would be 0.8. If we look at choice B, n times p would be 2.4. If we look at choice C, n times p would be 6.4. If we look at choice D, so now these ones say geometric, so we have to do 1 divided by p. 1 divided by 0.1 would be 10, and 1 divided by 0.2 would be 5. Okay. So remember, before we even looked at the answer choices, we just looked at the distribution, SOC-V'd it, and we said the center would be around 2.5. Looking at the answer choices, the only choice that produces a mean close to what we saw the center was is B. Okay. All right. Now, because we've got the computer here, let's just go to Staplet and see what happens when we go to binomial with n equals 8 and p equals 0.3. Can we do this? Yes, we can. All right. Oh, I just saw it right there. Okay, so let's refresh this, and then we're going to put 8 trials and probability of success 30%. Plot the distribution. Hey, that looks pretty much like what we're seeing there in the test question.